Hello, and welcome to your video lessons for Outcome 30.3 on set theory. Today, in our rubric, we are going to be looking at a whole bunch of definitions that relate to a given Venn diagram. We might also draw some Venn diagrams, and you will definitely learn the definition of a complement. So, again, Lesson 1 is all about what is a set and what are some of our set notation. So to begin, we are going to look at some definitions. So the first definition that we have is a set. A set is simply a collection of objects that are all distinguishable, which just means that they're all different from each other. So for example, we could have a set of whole numbers being 0, 1, 2, 3, 4, all the way up. Those are a set. You could have a set of fruits, right? It just lists off a bunch of fruits, that kind of thing. So a set is just a collection of objects that are all different from each other. An element, then, is just an object in that set. So for example, if you might have a set of whole numbers, 0, 1, 2, 3, 4, 5, 6, blah, 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 forever, 3 is just an element of that set. Okay, so an element is just a part of it. A universal set is basically, it is the large set in all of our examples. Here it just states that a universal set is a set of all the elements under consideration for any particular question. And quite often we will call it a sample space as we move on to probability. So we're going to do some work here with the next few definitions using a universal set of just our digits. So that our universal set is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Our large set. Every question will have a different universal set. So next, basically, we have is a complement. A complement is just elements of one set that don't belong to another subset of it. So for example, I have two subsets, O and O prime. When you see this little tick mark here, that simply is just read O prime. So O prime is a set, they use the wrong bracket here, it should be a squiggly bracket, 0, 2, 4, 6, and 8. That set is the complement of O, which is simply 1, 3, 5, 7, 9. Remembering that our universal set is D, which is those numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So my one set is O, 1, 3, 5, 7, 9. O prime are all the rest. Everything that's not in O. So again, 0, 2, 4, 6, 8. That is meant by a complement. An empty set is simply a set that has no elements in it. So when you have an empty set, you either use your squiggly brackets, again, squiggly brackets is really important, with nothing inside, or you have an O with a line through it, meaning there's nothing there. The word disjoint just means when you have two sets that have no elements in common. So for example, we just talked about even and odd numbers. Those elements are disjoint. If I were to draw a Venn diagram, I would have all of my even numbers in one circle and all of my odd numbers in another circle, and they would not overlap. That is what is meant by disjoint. They just have nothing in common. So there is all of our definitions. So let's quickly just summarize. So whenever you're making a set, whenever you're listing off the elements in a set, you need to make sure you're using the squiggly brackets. Using a circular or square bracket is going to be wrong in this case. So if we want, we can decide to have a universal set. Again, that's our large set, just being numbers 1, 2, and 3. When we list that set, again, notice how it's squiggly brackets. And then 1, 2, 3 are just listed in the brackets. You can make a set that's smaller. So let's just make a new set called A, and we want the numbers 1 and 2 in it. So again, my A set, again, notice how there's squiggly brackets, is just the numbers 1 and 2. Now you'll notice that the elements of A are also in U, right? If A is 1 and 2, and U is 1, 2, and 3, everything that's in A is also in U. We would say then that A is a subset of U. And it's this weird symbol here. That means subset. Or if it helps, just think of inside of. So A is inside of U. Or A is a subset of U. Right? If I were to draw it, I would have U being 1, 2, and 3. But then A is simply those ones. A is totally inside of U. Set A prime, again, remember that little ticky mark, just means it's a complement. So it's everything that's not in A, but it's in U. So the only thing that's not in A, that's also in U, is the number 3. So A prime is just 3. If we wanted to find another new set, B, being a subset of U that contains the number 4, well, there is no number 4 in U, so there's nothing in that set. So you would write B is an empty set, or B is that 0 with a line through it, meaning that there's nothing inside of it. B is still, though, a subset of U. The phrase 1 to 5 means 1 to 5 inclusive. So in set notation, if we wanted to call that set X, basically you would write X equals, and again, notice how there's squiggly brackets, the beginning and at the end, and then you list all of the numbers 1, 2, 3, 4, 5. The order does not matter when you write your numbers in. A new notation now is this N of X. Just means the number of elements. So if you look at set X, how many elements are in it? Well, there's 1, 2, 3, 4, 5, 5 elements in X. So don't get confused. The set X is the squiggly brackets with the numbers 1, 2, 3, 4, 5 in it. The number in X is how many there are. In that case, there's 5. So here's an example of a Venn diagram. So Brooke, she drew this Venn diagram. So she's got a few different sets. C, the one that is right here in the corner, that is my universal set. It is the large set. And that's normally where you'll find them, is up in the corner. And then she's got a few other sets. She's got a set F there in orange and the green. It's just fruit. S is a set of fruit that you can eat without peeling. And then V is your set of veggies. Do you agree with her descriptions? I say, yeah, it looks pretty good in terms of what she had. But there's really a lot of different ways that you could describe this. You could describe them in terms of color. You could describe them in terms of shape. You could describe them however you want. So, for example, if we wanted to use the color idea, we could list a whole bunch of new sets if I did another way. So I would still use C as my universal set. C would still be a list of all the produce. But I could now change to colors. I could have O, meaning everything that is orange. I could have, so that would be the set of the oranges and the carrots. Right? I could have a set of yellow produce, which would just be my bananas and my pineapple and my corn. And I'm just going to state the colors here. But you see the point, right? We could have all of our green elements, which would be my apples and my peas and my beans. And I could have all the brown things, which were just my potatoes and my pears. So again, I didn't list all the elements, but you would. I'm just trying to save a little bit of time, but that would be how you could also do it. C. C says, why does it make sense that S is a subset of F and S is a subset of C? Just remember that that little symbol here, this subset thing, also could be read as inside of. So if I look, is S inside of F? Absolutely. S is inside the larger F. Yep. And if I continued on, S is also inside of the larger universal set. So those are definitely true. D says, list the disjoint sets if there are any. Well, disjoint sets are the ones that have nothing in common, ones that do not overlap. So if I look at my picture, F and V do not overlap. Right? F is my large circle on the top, V is my large circle on the bottom. They do not overlap. I could even look at the small little s along with the big V on the bottom, and they don't overlap. So again, there are two disjoint sets. F is subset with V, and S is also a subset with V. E. Is F prime equal to V? So remember, F prime means everything that is not in F. So basically, if I look at it, F is everything inside of this large circle. So everything that's not in F. If I were to cover that thing completely up, I would be left solely with V on the bottom. So, yep, that is true. F. Determine the number in V, the number in F, and the number in C. So the number in V, I simply go to my V and I count. 1, 2, 3, 4, 5. There is 5 elements in V. Number in F. So F is the large circle. There is 1, 2, 3, 4, 5 in there. 5. The number in C is the large now universal set, which is basically everything that's there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, last but not least, it says list the elements that are in S prime. So S prime is everything that is not in S. So what's not in S? Everything that was in V, right? Your peas, your carrots, your potatoes, your corn, your beans. And now, though, if I scroll up, the things over here that are on the left, oranges, pineapples, and bananas, they are also not in S. So those also need to be included in my list. The oranges, the pineapple, and the banana. And again, notice how I started and ended with a squiggly bracket. One more example. So it says, draw a Venn diagram to show. We're going to make the universal set all the numbers from 1 to 40. E is going to be my multiples of 3, F is going to be my multiples of 15, and S is going to be my multiples of 9. So when I do questions like this, I just start by listing out my multiples. And I'm going to go from 1 and I'm going to stop as soon as I hit 40. So my multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and 39. That is that set. My multiples of 15 would be 15, 30, the next one's 45, too big, stop. My multiples of 9 are 9, 18, 27, 36, the next one's 45, too big. Everything else is not going to be in the circles, they'll be on the outside of my Venn diagram. So when I look at that, I'm trying to figure out how many circles to draw. The first thing I see is, if I look at F, F has 15 and 30 in it, and that is also right there. So F is totally inside of E. I can do the same thing down here, 9, 18, 27, and 36. S is also totally within E. So when I make my Venn diagram, we generally start with a large rectangle. Hopefully I made this big enough. My universal set is called U, and I put it on the corner. E is going to be my biggest set that I'm going to draw. I know that F is inside of there, and I also know that S is inside of there. So F is going to have the numbers 15 and 30 in it. S is going to have 9, 18, 27, and 36. And then the rest are going to go for E in the outside. So 3 goes here, 6, 12, we got 15, we need 21 in there, we need 24 in there, we need 27 is in there already, and 30. And if I missed one, I apologize, but I think I got those ones now. However, there is a whole whack of numbers that we haven't included that aren't there. And those just go here. So 1 is not there, 2, 3 is there, 4, 5, 7, 8, 10, 11, 13, 14, 16, 22, 23, 25, 26, 28, 29, 31, 32, 34, 35, 37. Oh, I'm running out of room. I'm putting them over here. 38 and 40. There is my Venn diagram. So now is each statement true? Sorry, is there any disjoint sets? Ones that do not overlap, well, F and S do not overlap, so they are disjoint. Sorry, and now on to is each statement true? So E is a subset of F. Is E inside of F? Nope, it is the other way around. Number 2, S is a subset of E. Is S inside of C? Sorry, is S inside of E? Absolutely it is. Is S inside of F? No, they are disjoint. And is S inside of S? Yep. And then last but not least, is F prime all the numbers from 1 to 40 except 15 and 30? So F prime is everything that's not in F, which would be all the numbers from 1 to 40 except for 15 and 30. So that is definitely true. And that concludes lesson number 1. Hope you learned a lot.